Hello and welcome to a video about triangle congruence proofs. I know that we went through these in class, but what I wanted to do is just put them on video so that if you need to go back, you can go back to them, take notes, and it'll help you with the end of quarter assessment. So in question number 1, we have one of our questions from before we started doing proofs. We just simply want to know the congruent statement of these two triangles here, specifically UVX congruent to UWX, where X is the midpoint of VW. So let's start to fill in information that we know. So we know right from looking at the triangles that I have a right angle or a perpendicular. This, due to the linear pair theorem, indicates a right angle on the other side of the linear pair, which gives me an angle. The second thing I see that we've been working with a while is a side that's equal to itself. So UX is equal to UX. This is called the reflexive property, and that gives me a side. And then lastly, we have the directions, which indicates that X is the midpoint of, so let me clean this up a little bit here, where X is the midpoint of VW. So if X is halfway between V and W, well, then I definitely have equal line segments on either side of the midpoint. So now if I mark down this side, I can indicate to myself the theorem that we would use, side angle side. Let's take a look actually at one of the proof problems. So here is a proof that has all givens. So in other words, we have two triangles with 3 sides equal. We know it's going to be side, side, side. We've been trained well enough to know what's going on there. And then I just have to start to match up the sides. So what we have here is, if I start with 1 to 1, right, I can do BA is to ED. So line segment BA is congruent to line segment ED. And this is by given. Usually. Now I'm going to look at 2 to 2, right? So I have BC is congruent to EF. And that's also given. And then lastly, I'm going to look at my third side here. Oh, well, we can see it's 3. So 3 to 3, and I have CA is congruent to FD. And that's also given. And now once I have these line segments all filled in my statements, I can write a congruent statement. The good news is that all the congruent statements will be given to you on the test, so you just have to figure out what it is. So we have ABC. So you don't have to figure it out what it is, I meant to say. Is congruent to DEF. And that's by side, side, side. So this goes to show you that, you could be given all of the statements needed to prove congruency. So let's take a look at one of the ones that you can expect on the test. So in this problem here, we have a set of given directions, right? And it says that AB is congruent to CD. So AB is congruent to CD. I'm going to mark that down on my diagram, and I'm going to write that as a statement. So we have AB congruent to CD, and that was given to me. Then after that, I have AD is equal to CB. So I'm going to mark that with 2 tally marks to differentiate the two equal sides, and I'm going to write that one. AD is congruent to CB, and that was also given. And then lastly, what we've kind of been trained to do now is recognize that reflexive side, right? So DB is congruent to DB, and that's by the reflexive property. Again, I have side, 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 but this time I'm given the proof statement. So all I have to do is copy down ABD is congruent to triangle CBD, and it's by side, side, side. So all you have to do is copy down the proof statement, and you get the last piece. Let's try the next one. Okay, so here I'm given not much. I'm given a diagram with some tally marks, so I know there's going to be some sides involved. And then it depends on what you know about these angles. So let's start with the sides. I got one tally mark to one tally mark. So I get YZ is equal to XZ. And that's given. Then I have another one here. I have VZ is equal to WZ. And that's also given. And then it's whether or not you can recognize the vertical angles, right? So it's on the study guide if you need it. But we have this angle here and this angle here, which is going to give me equal angles. So YZV is congruent to XZW. And that is by vertical angles. Now, again, they gave me the proof statement, which is nice. So triangle WXZ is congruent to triangle VYZ. And then I look back at the diagram, right? I have a side, we have an angle, and I have another side. Side, angle, side is going to be my congruent statement. All right, let's take a look at another one. Okay, here we, I can see the tally marks. So we know we're going to have some sides involved, and then we also have a midpoint. So let's start here. 1 is equal to 1. So here I have HJ is equal to HK. That's given. Then I have 2 and 2. So GJ is equal to IK. So GJ is congruent to IK. And that's also given. Then I have to go to this directions here. H is the midpoint of GI. So we've already kind of done one with a midpoint, but just a reminder. So if H is the midpoint of GI, then I can say that one side of the line segment is equal to the other side, which makes GH equal to IH. And that's by midpoint. Or definition of a midpoint is actually the full reason. And then finally, they give me the statement. So all I have to do is copy it down. Triangle HIK is congruent to HGJ. And just an analysis of the diagram, I can see it's by side, side, side. Let's try another one. In this problem, I can see that I have my perpendicular, right? So that I know that that's going to be involved. And I also see in the directions I have a midpoint. And I can see we have a reflexive side. So let's start to put this all together. So let's start with the angle. SVT, so angle SVT is congruent to SVU, and that's by perpendicular. Then let's go to the reflexive side, because we've already done one of those. So we have SV is congruent to SV, and that's by reflexive. And then finally, let's put that midpoint in. So again, we have TU line segment, and V is the midpoint. So in other words, I can say that both sides of the line segment to the left and right of V are equal. So we have TV equal to UV. And that's by midpoint. They once again give me the congruence statement, which is nice. So triangle STV is congruent to triangle SUV. And a quick look here, we have a side, an angle, and a side. So it's going to be my side angle side. Let's take a look at the next one. Okay, so here we have to complete the proof. We're given some things here, so we have to remember these are not tick marks. See how they're arrows? That's different. That means that they're parallel. So what they're saying here is that XY is parallel to WV. Right? So that's what they're indicating to us. Now, when that happens, and I also have a given angle and a reflexive side, right? So when that happens, opposite interior angles are equal. So if I'm standing outside the shape here, my interior angle is going to be to the other side of where I'm standing. Same thing if I'm standing out here, it's going to be to the other side. So I have opposite interior angles. I have a given angle, and don't forget about our reflexive side. So we have no givens in this case. The only given was parallel lines. So let's start to put it together. So I know that angle Y equals angle W, which was given. So we do have a given. Then I also have, let's do the reflexive side. So XV is congruent to XV, and that's by reflexive. And then finally, let's get these angles in here. Angle VXW is congruent to angle XVY. And that's by, we'll call it parallel lines for space room. And then they give me the congruent statement, triangle VXY is congruent to triangle XVW. And if I take a look, I have a given angle, the parallel line angle, and a side is going to be angle, side. Let's take a look at another one. So I'm given I have some givens here. We have a side, an angle, and then I am also given that triangle TUW is equilateral. So let's start to fill in some of these things. So here we have one tick mark to one tick mark. So UV is equal to TX. And that's a given. I also have some angles here. So I have this angle and I have this angle, right? So angle VUW is congruent to angle XTW, and that's also given. And now let's address this equilateral triangle thing here. So we have triangle TUW. All right. So now once you've identified where that triangle is, equilateral means equal sides and equal angles. So I can already tell that we're only going to really need the sides. So let's put in 3 equal sides here. And then from this, really, I don't really need TU, but the other sides are going to come in, are going to come in handy. So let's get those sides down. UW is congruent to TW. And that is by the definition of an equilateral triangle. And then finally, we are given the proof statement, right? So we have triangle TWX is congruent to triangle UWV. And that's going to be by, well, we have a side, an angle, and a side, angle, side. All right. We have one more question today. The question is on, I'm covering the problem. The question is on a bisector. All right. Then we're also given an equal side, and that's it. So let's start to fill in some of this information here. So we have first FI bisects GFH. So let's find GFH. So GFH. All right. So there's that angle, and we can see that FI is right here. So I know that this angle is equal to that angle. Let's get that down. GFI, so angle GFI is going to be congruent to HFI. And that's by the definition of an angle bisector. All right, then we'll see what else we got here. FG is congruent to FH. So we have FG congruent to FH. All right. So let's get that down. and that's given. And then lastly, we have actually a reflexive side here. Fi is congruent to Fi by the reflexive property. And then we have our proof statement right here. So triangle FGI is congruent to FHI. Quick look back at our diagram here. I have a side, an angle, and a side. That's also going to be by side angle side. All right, so those are all the questions that we did in class, and now you can rewatch the demonstration and slow it down, pause it at times, and it should help you complete the test. If you have any questions, feel free to email me, and we'll help you through it. Thanks.